Hello everybody, my name is Sergey. I'm working at Intel in OpenVINO project. I will describe the role that ONNX plays in OpenVINO ecosystem, connecting us to deep learning frameworks and what services we are providing for ONNX in OpenVINO. Let's start. First of all, what is OpenVINO? OpenVINO is the end-to-end solution for inference across Intel hardware. I use end-to-end term here because OpenVINO accepts the model in deep learning framework format just after the training and can give you the result of the inference on various kinds of supported Intel hardware available on your system. OpenVINO ecosystem includes a number of tools, but as we are talking about inference first, the central component is inference engine. It provides an API to build Python or C++ applications to run the inference. Inference engine as a component doesn't have any code for inference. Instead, it relies on plugins. Each plugin is dedicated to run the inference on a particular hardware. So the user has a common API to run inference on any supported hardware, just configuring plugin name. Besides pure hardware plugins, we also have kind of meta plugins. They combine capabilities of multiple pure hardware plugins underneath. The goal for such meta plugins is to simplify selection of the device or use several available devices simultaneously to achieve better performance. Okay, let's extend the picture to opposite direction, describing where the model comes from. Inference engine loads the model represented in OpenVINO intermediate representation. It is produced by a separate component that is called Model Optimizer. Model Optimizer can load various types of the original models from deep learning frameworks and convert it to IR. ONNX is one of the formats that we can read. Running Model Optimizer offline outside the main inference application, we are minimizing time to the first inference, improving user experience, and minimizing binary size for deployment. By the way, there are other techniques available in OpenVINO that speed up first inference time, like caching and offline compilation. The important tool that optimizes models for int8 execution is post-training optimization tool, which allows you to significantly speed up the inference, maintaining the desired accuracy in the same time, with the help of accuracy checker running on your dataset. So, what is OpenVINO ecosystem? Besides components that we have just mentioned, it contains many others, like Open Model Zoo, training extension, deep learning workbench, tools to annotate and work with datasets, and even more. Part of the components push us beyond just the inference tasks. You can visit the documentation for more information about OpenVINO and our GitHub repository where all these components are being developed. Okay, let's take a closer look at ONNX support inside OpenVINO. ONNX is not just another format for model representation. Besides this flow, where we can convert ONNX with Model Optimizer to IR, just like other file formats we have supporting, uh, we have something that is currently available for ONNX only. We can load ONNX model directly to inference engine runtime, skipping all the offline steps. So if you want to use the model out of the box and don't need any preparation offline, skip the offline conversion step. In the code, it looks like this. Regardless of the language we use to write the application, the steps are quite similar in C++ and Python. First, create the core object, which is an entry point for the inference API. It allows to read the models and load them to plugins. Here we are reading model from ONNX file. After reading, you can do some model adjustment, like setting a new input shape for model inputs. And then load to one of the plugins to run the inference. In this example, it is CPU device. These steps are identical to the steps that we are doing for normal OpenVINO IR presented here. where model XML is used, which is OpenVINO IR file. Thus, OpenVINO IR and ONNX files are completely interchangeable from the inference API perspective, and user can choose whether to convert from ONNX to OpenVINO IR in offline step, saving time to the first inference in the target application, or to load ONNX model directly and spend some time for conversion. The latter unlocks more rapid prototyping. So, what we are doing to make OpenVINO a good inference solution for ONNX models? First of all, constantly growing support for operators. Our main priority is operators from the popular models and models from the customers. Each new ONNX operator can be supported in two ways. First, it can be decomposed to a subgraph of existing operations from official OpenVINO operation set. The second way is when such decomposition is not possible or too bulky and inefficient. In this case, we are extending our operation set to cover this ONNX operator. The latter case implies more efforts because such operation should be implemented in all the inference plugins. The ONNX community can help us to grow faster, to build really complete ONNX backend by providing feature requests and highlighting existing problems in the current ONNX support. I encourage to create tickets at OpenVINO GitHub to achieve that. We are constantly monitoring such external requests and it helps us to make the right decisions in the development. Okay, let's move to another aspect. For us, ONNX provides important connection to very popular world of PyTorch models. In OpenVINO, we depend on Torch ONNX functionality to obtain serialized models from PyTorch. If the original model cannot be expressed in the default ONNX offset, by using Torch ONNX functionality, you can still serialize such models in ONNX file, and then using OpenVINO extensions, the user can write the inference code for such custom operations in OpenVINO plugins. As we can read ONNX models directly in inference application without using an offline step with model optimizer, you can call OpenVINO inference right in your PyTorch application to evaluate performance opportunities. The corresponding code looks like this. Here we are serializing the model to a temporary ONNX file, and immediately after that we load it to an OpenVINO inference engine. Or this code can be modified to avoid storing a model to a temporary file and make the trick in the memory buffer. So that's all I can highlight in this short presentation.